at Enthuse. And today we are going to talk about conduction like the title suggests. And I'm pretty sure you would have wondered how heat travels. What are the different modes of heat traveling through solids, liquids and gases? And I'm pretty sure you would have definitely touched a hot pan which is on a stove or something, and you should have wondered how did the heat travel from the flame to your hand. And that's what we're going to discuss today with me, Shreyas, your master teacher for physics at Vedantu, going live on this very own channel of yours, Enthuse. Welcome all the minions out here. So let me give you a quick introduction about myself for all the new members of our family out here on Enthuse. So guys, this is Shreyas here. I'm the physics master teacher and I have been training kids for JEE, for NEET, for Olympiads and you name it for a very long time. And many of my kids have successfully qualified, not just in fact qualified, in fact aced the examinations with really great ranks. And I myself qualified for IIT, a long time back when I was your age. And I got almost full marks in physics, and I really hope that my ideas can change the way in which you interpret things. So I'm pretty sure that's why you're here to learn from us, and let me assure you that we are going to dedicate all our time, all our energy for your upliftment, for making sure that you score really well and making sure that you do not repeat those mistakes which your seniors did, or probably those mistakes which we did. So hello everyone, hello Kirito, Yalni, VK, Aishwarya, Enchanted, Fida, hello everyone, hello Bikaushik, hello Rita. So one way to make sure you're noticed and make sure that your attendance is marked is interact with all the other minions out here, because the only way others will know more about you and you can make friends and you will have that motivation to come to the class is by making more friends. So go ahead, interact, introduce yourselves, and all the other minions should also welcome them. And you know what, minions, you should also take care that our chat box is clean and make sure that none of the virus enters our system. So you know what I mean, So let's get going. Hello Kiran, hi Vijay, hi Arman, good evening everyone. So if you want, you can also follow me on Instagram. So I'll just let you know my social media handle, and that's Shreyas_Vedantu on Instagram. So where I keep posting a lot of updates, a lot of important notifications, a lot of motivational quotes, memes and stuff like that. So do feel free to tag me over there and follow me on Instagram out here. Okay. And before we begin the lecture, I know all the new family members. Yes, in case you have forgotten to hit the subscribe button, please do it now, because now is the time to get your free membership. Yes, absolutely free. If you hit the subscribe button, no cost. Yes, zero cost. In fact, you will get a lot of things in return. And go smash that like button out there, because your smash is very important to all of us. And you know why? Because we are going to get all the energy to conduct these lovely, wonderful sessions for you, dedicate all our time and energy for you because of your sincere love and effort. Yes. Okay. Hello Arman. Hi Sean. Hello Vijay. Hello Rita. Hello Varun. Wow, so many new minions are out here. Yes, let's begin with the session then with Hi Josh. I hope everybody is ready to first of all see the timetable. So this week it's all devoted to thermodynamics. So today is conduction, tomorrow is radiation, and there is going to be a marathon session on complete thermodynamics, the first law, the engines and stuff like that. And electromagnetic induction continued. AC and LCR circuits, one of the most requested topics by 12th standard students. So these are 11th standard topics, but obviously 12th standard students should also attend it in case these concepts are not clear. And 2021 aspirants, that is the people who are going to write JEE Mains, we are going to conduct a very special session for all of you. Most important and expected topics in physics. Very important session on Thursday, and Saturday a mock test with the most expected questions which might come in the upcoming examinations. So that's on Saturday. So let's begin. Now, how many of you have ever had that opportunity, that privilege to sit in front of a bonfire, maybe on a cold night, and get some warmth and maybe roast some, I don't know, tandoori, or maybe have some nice kebabs. How many of you minions have done this? Yes, Arman, thank you. Happy February. A lot of things are going to happen in February, including Valentine's and JEE Mains. That's how it is. No, not many of you. Nimagada Sarat Chandra, the expansion in solid session was conducted last week. So please watch the replay. The playlist is already created. You can check out the past videos. Okay, Sarat Chandra? Yes, many times. Never done that, Princey. Oh, don't worry, don't worry. I'm pretty sure once you guys enter into IITs, NITs, AIMS, AFMC, or BITS, or whichever college you're going to get into, I'm pretty sure you're going to have a gala time with all your friends and probably a lot of stories to share. And when you take that heat comes via 3 different forms depending on how you're getting access to it. Number 1 is the air which flows towards you. There will be wind, hot wind, which will be blowing over you. That wind is carrying that energy, the thermal energy on you, on your face, on your hands. That is convection, that wind which is carrying that energy. Second one, if you are having a nice barbecue session and you're roasting something, then that heat will flow via that rod through conduction. That you can see that heat flowing. And even when there is no wind blowing, even if the air is still, you will still feel some warmth even if you are quite some distance away, and that is radiation. So radiation is something which does not actually require any medium. Convection is something which requires medium, and even conduction requires medium. Radiation as such can even happen without the medium. That's very important. Now if I ask you a question, out of these 3, convection, conduction and radiation, who is the fastest? Come on guys, let me know. Who is the fastest? Which of the 3 modes of heat transfer do you think is the fastest, and which one do you think is the slowest? Hello Priyanka, welcome. Which one is fastest and which one is slowest? Who is fast, who is slow? Come on, who do you think will conduct heat really fast? All right, some of you are saying convection, some of you are saying conduction. Come on, all the minions. These kind of questions can definitely come in JEE Mains as simple questions as well, and you cannot afford to lose marks in such type of questions. Conduction is fastest, convection, radiation, conduction. Okay, radiation. All right. Hello Ankit. Okay, Naveen says conduction, Arman says conduction. So well, let me tell you, the correct answer is actually radiation, because radiation is through electromagnetic waves, just like light, and light travels really fast, we all know, at 3 lakh kilometers per second, and that's very important. So radiation is fastest, understand. The next one is convection. The wind can blow really fast, but not as fast as the speed of light, of course. So the second in the race will be convection. The wind blowing can carry some energy. This conduction is really slow. It takes some time, and you will know why it takes some time in a bit, but conduction is the slowest among all of them. Also, one more thing. Out of these 3 modes, understand only 2 of them need medium. Which are the 2 ones which require medium? Convection and conduction. These 2 require medium. Radiation does not require medium. Keep this in mind. Okay. Number 3, third point which you should remember. So we have talked about medium, we have talked about speed, we have talked about the theory, etc. Next, which is important, is remember this guys, primarily in solids, the mode which is more common, okay, amongst convection and conduction. If you compare conduction and convection, obviously it's conduction. Convection can't happen in solids because the molecules, the atoms cannot move. Understand? So the molecules cannot move, they are fixed to their original place. So in solids it's only conduction, but in liquids and in gases, the wind, the fluid can flow from point A to point B. So the most common thing that happens in liquids or in gases is convection. Understand that. Radiation can happen in all the 3 things. It could happen for solids, it could happen for liquids, it could happen for gases. All 3 things can encounter radiation. I hope this is very, very clear. Ankit, I'll definitely answer. I read your comment just before some time. Definitely I'll answer your query, Ankit. After this lecture is over, in the comment section, I'll reply in fact to your comment, Ankit. Don't worry. Okay? Cool. No problem, VK. Okay. Clearo? Next up. So this is what exactly conduction is. So look at these dudes. These green books are nothing but the heat. And you can see how the heat flows from one particle to the other particle, or one person to the other person, without these gentlemen out here moving or displacing. Look at this. These gentlemen are locked to their respective positions. So that's what I was saying. In solids, the particles do not move. It's only the energy which moves. So heat is like that energy which is flowing. The particles are as it is. The energy goes from one point to the other. Unless a person lifts the book and he himself moves to the other side, then that would be called as convection. I hope this is clear. So if a person lifts the book and he goes himself from one place to the other, that would be convection. This is conduction. I hope this is clear. Very good. Now, let's talk about some formula based stuff out here. So let's talk about heat transfer in conduction. Yes. Now, it is found out experimentally that if the one end is hot, this is TH, temperature of the hot end, and there is a rod and the heat is flowing. The heat is flowing from the hot side to the cold side. TC stands for the cold temperature. Then the rate at which the heat flows depends on few things. Number one, the length of that conducting rod or object, and also the area of cross section. So the area of cross section, the length and the temperature, all of this decided. And what is the relationship? Here it is. Rate of heat flow, dq by dt. This is nothing but rate of heat flow. All right. Sometimes it is also called as heat current. Okay, this heat current is proportional to the length. Okay, it is it's proportional to the area, it's inversely proportional to the length, and it is also proportional to the temperature difference. Very important. It's proportional to temperature difference, area, and inversely proportional to length. More the length, less is the heat transfer, because it has to travel a lot of distance. And therefore, the heat transfer formula dq by dt, okay, is going to be some constant into area into hot temperature minus the cold temperature divided by the length across which the heat is flowing. So this is the formula which you should know. I know you might be wondering, what the hell is this K? Well, this is nothing but conductivity. It's the conductivity of that material, and you can guess the units. It's not that difficult. dq by dt is watts. Okay, area is meter square, length is meter. So 1 meter will go away because of this length and area, and that meter will go downstairs, so it will become per meter, and temperature difference will come down, so it would be per degree Celsius or per Kelvin. Up to you how you want to write it. So if you want to write it in SI, usually we are going to put Kelvin out here. All right, so that's how it is. So this K is the conductivity, and it completely depends on the material, nothing else. If it's wood, it's something else. If it's iron, it's something else. That will be given, or you have to find out based on the other pieces of information. I hope this is clear. So SL is asking, is it TH minus TC or TC minus TH? SL, my logic is very simple. See, just like when you write spring force, right? You write it as Kx. Don't bother about the minus sign. Minus tells you the direction. Same way over here, some books use that minus, plus, etc. Weird conventions. Just remember, heat will flow from hot to cold. That's it. So that's all that you need to know. So that's why I'll just put it as hot minus cold. I'll keep it positive. Sometimes you might not know who is hot, who is cold. In those cases, assume one is hot, assume the other is cold, and solve the problem accordingly. If you're wrong in the assumption, in the end, you will probably get a minus sign, and that will tell you accordingly. I hope that's clear. Yes, it's very important, Aishwarya, for JEE because it's very easy. Yes, it's very important because for JEE, this is very simple and every time a question can come, and you will see the problems are simple and you can score these marks very easily. So do not leave these chapters for sure. That's why I created a one-shot series for all of you, so that you can grasp all the knowledge that is required in one shot. Okay, cool. I hope this is clear. Now, next up over here is understand when a rod is conducting. Okay, when a rod is conducting, one side is hot, one side is cold. If you have thermometers placed at different places, you will see the thermometer will not measure the same reading. It will be different. At the hot side, it will be hotter. At the cold side, it will be colder. And if you probably draw a line, that will be very interesting. That line passes like this. Okay, it's a straight line. That's very important. And if you notice, if I travel a distance of something over here, let's say dx, the temperature changes by dt. Look at this. The temperature changes by dt if I travel a distance of dx. So hence, I define a new term called as temperature gradient, and that is nothing but dt by dx. Keep this in mind, dt by dx. Very, very important. Next point, which is also very important over here, is whatever heat flows inside, dq by dt in, very, very important, is also the rate at which the heat comes outside, dq by dt out. Reminds me of equation of continuity. So whatever heat goes inside also comes outside. So you might be wondering, why shouldn't it be less or more? The reason for that is simple. When the temperature gradient is set up and everything is steady, all right, whatever heat goes here will not be absorbed by the rod. Nothing is absorbed. So nothing is absorbed in the steady state. Very, very important, steady state. So whatever goes in goes out. It's like equation of continuity in fluids. Okay. Now that means no matter which cross section you take of this rod, the heat flow rate in should be heat flow rate out, and it will be constant no matter which cross section you take. So that means if I take a cross section like this, let's say I call it dx, and let's say the temperature difference between these 2 points, is dt, then whatever heat is flowing through it, which is dq by dt, through that cross section of area A, that dq by dt can be written down as dq by dt is Ka dt by dx. You can see that this formula is very similar to the formula we wrote in the previous slide. Ka, temperature difference by length. Instead of a big length and big temperature difference, it's small length upon small length. Temperature difference. So this dt by dx is called temperature gradient. And remember, this dq by dt is constant in steady state. Whatever goes in, it goes out. I hope this is clear. Amazing, amazing. Very good, guys. You guys are understanding a lot. And believe me, this session will definitely give you those marks which you require for the upcoming JEE Mains or the next year JEE Mains examination, whenever you're going to write it. And you're going to remember all these slides. Whenever a conceptual question comes, theoretical question comes, or even formula based question comes, or a numerical question comes, you will be able to solve everything just by attending today's lecture. And all these forms are very important because I have been teaching for a long time and I know what is important, what is not important. Yes, like plus 4 marks in JEE SL, and that 4 marks is going to probably save you from getting a branch or getting a college, and probably will remember, yes, each lecture that you attend will help you score that plus 3, plus 4, plus 3, plus 4 marks, and then when you accumulate it, it becomes a huge sum of score. Okay, now let's get going ahead. So like I was saying, thermal conductivity depends on the medium. So aluminum nitride, for example, don't have to remember, this is just an example, has very good thermal conductivity. So the moment you heat, you can see how temperature quickly flows. But for a low conductivity material, the temperature flows very slowly. So that's how K differs the rate of heat flow. And these are some constants. Again, warning, do not remember. This is just to give you a sense or an idea. So diamond has crazy conductivity. Silver, copper, gold, aluminium, metals of course have good conductivity. Iron, yes. Glass, not so much. Brick, water, wood, helium. Oh my god, look at their conductivity is very low. They are bad conductors of heat. So lower K, bad conductors, higher K, good conductors. I hope this makes sense. Yes, I hope this is clear. Diya, if you have forgotten whatever you studied in heat transfer, then definitely you should watch this, because Diya, these are one shot series. So in one shot, that means everything will be covered in that one lecture. Whatever topic is mentioned in that description box, everything will be covered in that one lecture. So you should definitely attend it. So that's how it is. Don't worry, Krish, me about KVPY. Guys, now focus on the session. Whatever happened, happened. We are now going to focus on the next race. And what is your next race, guys? JEE Mains examination. So come on, let's prepare for that. Next up is this very important slide, which is going to definitely save you some time in the examination. Everybody knows Ohm's law for electrical circuits. If you have some resistance and if you have some current flowing in the wire, then the potential difference is equal to the current multiplied by the resistance. So potential difference, let's say delta V, there is some voltage here, there is some voltage here. Potential difference is current into R. That is Ohm's law in current electricity. Similarly, this material will have some K, it will have some area of cross section, and of course some length. And there is obviously some heat which is flowing, dQ, some dQ by dt. Now let's rewrite these terms and see what happens. dQ by dt is equal to Ka delta T by length. Rearranging it, I'll get delta T is equal to dQ by dt as it is, okay, into L goes on the top, K and A come below. This is what I get. Now you can easily compare. This is nothing but temperature difference. This is nothing but heat current, correct? This is rate of flow of heat, so heat current, and this is nothing but thermal resistance. This is thermal resistance, very important, and this is something which you should remember. L by Ka is thermal resistance. L by Ka is thermal resistance. Remember this again, repeat it after me. L by K is thermal resistance, dQ by dt is heat current, delta T is temperature difference, very similar to Ohm's law. Potential difference is current into resistance. That's how it is. Okay. Yes, Diya, you can go back, slide the video a little bit behind, and you can, yes, watch it at 2x speed like Aishwarya suggested, so that you can catch up to wherever we are. Don't worry, you will definitely catch up. Yes, correcto, bingo. Now I'll tell you why this is important, because there will be some problems, guys. Something like this. There is a rod like this, and there is another rod like this, and there is another rod like this, and there is another rod like this, and there is probably something like this, and they are all connected. Again, a rod here, and the question will be, what is the rate of flow of heat and stuff like that. When you have problems like this, you can always convert it into resistance problem. This is like a resistor, okay. This is also like a resistor, okay. That is also like a resistor, and there is a resistor here, and there is a resistor here. So you will get all these rods, first of all, converted into resistances. Remember, each resistance is that length by that rod's K into that A. Now you know how to solve this problem. You can definitely convert this into one single resistance, so that will be the equivalent rod of that system. That's how you can solve the problems. I hope this is clear. Every minion is understanding this, all the minions out there. I hope this concept is clear. Yes, the resistors analogy is answer to everything. And if you love this analogy, go smash that like button out there. And if you're a new user, go hit the subscribe button out there. Okay, let's begin with some problems. And before we start the problems, I have some important piece of information to give you. So some of you are new. I know some of you know this already, but just to tell you, guys, it's very important to know the schedule of the crash course. This is the physics schedule for the crash course, which has started from 28. But don't have to worry, you can always watch the replay. Yes, you can watch replays of whatever parts you have missed. How many times? 100 times, 1000 times. There is no restriction to that. So whatever lectures you have missed, okay, so please watch the replays in case you are joining the crash course. And even if you miss a lecture ahead or you want to revise any lecture, you can watch the replays any number of times. Like you can see in this crash course, all topics right from mechanics, simple harmonic motion, fluids, thermal physics, capacitance, magnetism, modern physics, semiconductors, all topics get covered. This is the schedule. Same thing is with chemistry, right from physical, inorganic and organic. All the chapters get covered. Hello Shreya, hello everyone. So Saurav, I think you are a little bit late. Please rewind back the lecture and watch it again. Yes, and this is the timetable for mathematics, right from algebra, geometry, calculus, differential equations, conic sections, probability, everything gets covered in these sessions. And remember, these are both 11th and 12th standard sessions gets covered in the crash course. So that's very important. So what and all are the secret ingredients for the successful recipe so that you crack the JEE Mains examination? So see guys, there are only few things that you need in the last few weeks. Number one, obviously you need all the syllabus coverage from the scratch. That is something which I just showed it to you. Number two, you need doubt solving. Yes, you want someone who is an expert and who can solve all your doubts right from the scratch and instantaneously, right from morning till night. And that's what we give you over here. And also you want practice tests, mock tests, discussions and analysis. That is something that you get in plenty. In fact, there are 20 mock tests planned in this crash course. And also some special strategy sessions by our very own Anand Sir, Pulkit Sir and other great master teachers out here. And also whatever will be taught, you will get notes, you will get assignments, also handwritten lecture notes of every day's session. You can download it as a PDF free of cost, of course. And there is no limitation on doubts also. You can ask hundreds of doubts. There is no limitation out there. And yes, so this is very important guys. You have to revise in a very specific manner. So these crash courses are not taught by any new teachers out here. They are experienced teachers whom I know them personally from a long time. Yes, that is very, very important for all of you. Now, let me tell you that where you can find this crash course is down there in the description box. After the video ends or probably now, you can just open it up in a separate tab, check out all the details. And do not forget to click on the enroll button and use the coupon code SHCC. That's very important because when you use the coupon code, only then you will get 20% off of this 10,000 rupees. So the usual price is 10,000. The course fee that you get because of attending today's class is 8,000 rupees. That's hardly anything. That's peanuts considering what you guys are going to get. So do consider because the batch has already started. So just 2 days, it's okay, you can catch up, but it's worth it. You'll definitely realize the true value. The true value of this is not 8,000. The true value of this is millions of dollars because it's going to change your life. So this is not the value of the course. Please keep this in mind. The value of the course is your life. So do not risk your life just looking at some random things. So do consider it. Check out the description box after the video. We will also start now solving some problems. 2009 previous year question. A long metallic bar is carrying heat. Okay, it's carrying heat from one end to the other end under steady state. That's given. The variation of the temperature, they have used the symbol theta. That's okay. Along the length x of the bar from the hot end is described best by which of the following graphs? Check it out and let me know. All right. Come on, come on, come on, come on. Think, 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 think. Very good. So looks like a lot of minions out here would have definitely scored if you would have attempted this paper in 2009. But I'm pretty sure, minions, you're going to do really well in 2021 and 22, depending on whichever year you're going to write it. Yes, the correct answer is actually this one, because I just told you the formula. Yes, I just told you the formula. dq by dt. Remember, dq by dt, which is with respect to time, is Ka. Temperature difference is d theta by dx. Since this is a constant, okay, this is a constant, area is a constant, therefore d theta by dx is also going to be a constant. That means theta is proportional to x, linear relationship. Whether it is positive or negative, that's secondary, but it is going to be a straight line. That's very important. Now if you see all the graphs, none of them were straight lines apart from this. But there is a catch. What if there were two options? One option was like this. Let's say this was A, and let's say I call this option E. How will I choose between A and E? That's the catch. So guys, remember that they have asked that it is measured from the hot end. X is measured from the hot end. So where will heat flow? From hot to cold. So what will happen? Temperature should drop. So that's why, even though both the graphs are straight, be careful, do not mark this one. Only this one will be correct in case this option comes. Yes, I hope this is clear. Very good. Let's see the next question coming up on your screen. Two ends of a conducting rod. Okay, these are the two ends of a conducting rod of varying cross section. You can see that this area is big, that area is small, so it's varying, are maintained at 200 and 0. So this black one is 200, this one is 0. Then in the steady state, which of the following options are true? Correct. Come on, think about it. Come on, think about it. Yes. Come on, minions, everyone. I want everyone to answer this question. dq by dt sort of is heat current, and K is thermal conductivity. L by K is thermal resistance. You can also rewind back. All right, some of you are saying B, some of you are saying C. Come on, minions. Decide, make up your mind. Come on, all the newbies out here, don't feel shy. Feel free, nobody is going to judge you. Even if you answer all questions wrong, you're still my favorites, and all the minions also will love you. Trust me, nobody judges over here. That's the speciality of this channel. Nobody is going to put anybody down. All right. So let's see what's the correct answer. Now, see guys, I'll tell you how to solve this. Q flowing through them is the same no matter which cross section you choose. dq by dt is the same for all cross sections. That's very important. Why? Since whatever goes in should go out. So it's like current. This part, this part, this part, all of them have same dq by dt. Now what was dq by dt? Try to recollect. What was dq by dt? It was K A dt by dx. Acha. So the question is temperature difference across AB and acha. Okay. So guys, if this is constant, area is varying, and this part and this part both have the same x. That means what is different? Only temperature is different. Only temperature is different. K is also same. Area is different. X is same. dq by dt is same. Think about it. Temperature difference is inversely proportional to area. Do you see that? Temperature difference into area is constant. That means temperature difference is inversely proportional to the area. So whichever has bigger area, who has bigger area? This has bigger area. This has smaller area. So delta T will be less here and delta T will be more here. So which option is correct? Come on, I hope this is clear. I hope this is clear. Yes, yes, correct guys. That's option C. Very good, minions. Is it understood how to solve these questions logically? Yes, yes. Okay, let's get going. Yes, Ankit, you can. But I'll answer your query. I know you have asked that question in the comment section in one of the previous videos. I'll answer it over there. Don't worry. Okay, yes. Now, 2004 question. Very good question. Let's see. If you wrote the exam in 2004, will you be able to solve it? Will you be able to grasp the concept and idea behind it? Let's see. The temperatures of two outer surfaces of a composite slab, meaning there are two slabs one after the other. Materials have conductivity K and 2K. So they are different materials, K and 2K. Thickness is also different, X and 4X. T2 and T1 are the final temperatures, this side and that side. What is the rate of heat flow in steady state? If it is in this form, okay, you have to find what is that F equal to. So the final answer comes like this. The question is, what is F? So I've shown the composite slab. I hope you can see this. This gray part has thickness X, conductivity K. The blue part has conductivity 2K and length or thickness 4X. This side is T2, let's say. That side is T1. That's what is given. Okay. Now, let me also mark the other things out here which is required. Like this one is X, of course. And this one is given to be 4X. You can see that. Okay. Now, how is heat flowing through this? How is heat flowing through this? Heat is flowing through this like this. Heat is flowing through this like this. Isn't it? It's flowing through this like this. This is dq by dt. Now, whatever heat flows through the first slab should flow through the second slab because there is no escape route out. Nothing can come in, nothing can go out. Whatever goes through this must go there because there is no escape way or there is no additional in route for heat to enter. So heat flow rate through both of them must be the same. That's my starting point. dq by dt through the first slab will be dq by dt through the second slab. See if everybody has understood this part. See if everybody has understood this part. All the minions out there understanding this? Very good, very good, very good. Very good. Savage, you were born in 2004. My goodness. Savage, somewhere around that time I was writing JEE. Okay, so that talks about the age difference, I guess. All right, cool. So Nike, what is happening is whatever heat comes from hotter side will have to go to the colder side, but the heat flows will it will have to go through both the slabs. There is no way in which it can go out or it can come in. So heat flow through both the slabs must be same. So dq by dt in 1 should be equal to dq by dt in 2. All right, I hope this is clear. Cool. Now, here it comes. If, think about it, dq by dt for this slab is asked, it will be K is the conductivity, A is the area, temperature difference. Oh, that's the catch. So what is the temperature of this junction which is there, the sandwich point? Sandwiches make me hungry, guys. Anyways, so this is T2, this is T, that is T1. T2 is more than T, T is more than T1 because heat is flowing from hot to cold to colder. So this is hot, this is cold, this is colder. That's how it is. Heat will flow from hot to cold to colder. So it will be Ka, be careful, hot minus cold. T2 minus T divided by, okay, divided by the length. How much is the length? X. And over here, what is the K? K is 2K. Area is obviously the same. And temperature, hot minus cold. Relatively, this is hotter. Think about it. So hot minus cold. Do not confuse with the signs. T minus T1 divided by the total length. How much is the total length? It is 4x. That's how you will get it. I hope this is clear. Now cancel out all the common terms, okay, and start solving the stuff. So I hope till this point everything is clear. So what you will get is 4 times. Yes, you will get 4 times of T2 minus T is 2 times of T minus T1. Oh, and that 2 and this 4 will also, acha, no, I have taken that 2 over there, so no problem. Now I can cancel it. This 2 and this 2 will get cancelled out here. Okay, so now I have 2T2 minus 2T is equal to T minus T1. Okay, now I can shift it over there and I can bring it over here. Just check this out. I hope everything is up to speed. Okay, just check this out. Okay, so I will get this value of T as, okay, I'll get the value of T as, you know, just think about it, 3T is equal to 2T2 plus T1. Okay, I'll get the value of 3T as 2T2 plus T1. I hope this is clear. Okay, now let's see what we can do. Let's see what we can do. The question is, what is the heat flow rate? The question is, what is the heat flow rate? So what we can do is that dq by dt eventually is, think about it, you can find either in this or in this, doesn't matter, either you find in this or you find it in that, it's one and the same thing. So you are just going to get K, in this is K, A is A, temperature difference T2 minus T. Now that T you put it from here, remember that T which you get from here, which is 2T2 plus T1 by 3. So 2T2 plus T1 divided by 3, just put it from there, divided by that length which is there, which is nothing but X. Just put it from there, that's it, and you will get the answer, and you will get the answer. Just see how much you are getting. So that dq by dt will be equal to, check this out guys, what and all is going to happen, Ka. So you're going to have 3T2 minus 2T1. 3T2 minus 2T1 is how much? Sorry, 3T2 minus 2T2, which is going to be 1T2. 1T2. I hope this is clear. 1T2. I hope this is clear. Minus T1 and the whole thing divided by 3, whole thing divided by X. So this is going to be Ka T2 minus T1 divided by 3X. So I know the value of F. So what is the value of F? F is 1 by 3. I did not write dA by dt. This is dq by dt. This is dq by dt. No Chaitanya, I don't have any prediction. Nobody should predict right now. You should just concentrate on JEE Mains right now. But it is going to be somewhere around the previous lines. Maybe the cutoff might go slightly higher because the paper was slightly easy. Yes, great. Understood how this is solved? Very good, very good. Cool, cool. Now, let's get going ahead to the next question. Okay, 1 by 3 is the answer. 2007 question. Now, this question scared everyone looking at the options. They're like, my goodness, look at these options. They look so scary, but trust me, it is not scary. Let's solve them together. Let's solve them together. So, one end of the rod, thermally insulated rod, is kept at temperature T1. The other is at temperature T2. The rod is composed of 2 sections of length L1, L2. Conductivities are given. The temperature at the junction is asked. Okay, let's see how do we solve this particular question. The question is find the junction's temperature, find T over here. Let's try to figure this out. How are we going to do this? Isn't it very similar to the question we solved before? Do you see how JEE is asking the same concept again and again with different varieties or different approaches? That's how you can see it. So the heat flow rate through this and the heat flow rate through that is the same. So dq by dt through both of them is the same, guys. So yes. So just start with that. dq by dt through the first rod is dq by dt through the second rod. Now let's start solving. I just want to solve this for you. So again, it will be K is K1, A is the same. Temperature difference T1 minus T. So T1 minus T divided by length. Length is L1 is equal to K2 A T minus T2. T minus T2 divided by that length which is L2. Area goes, multiply, cross multiply, and you will get K1 L2, T1 minus T is equal to K2 L1, alright, K2 L1, T minus T2. Now expand this further and you will get K1 L2 T1 minus K1 L2 T is equal to K2 L1 T minus K2 L1 T2. Great. Now next thing that I'm going to do, this term and this term I'm going to bring it together, and these two terms I'm going to bring it together. So what is going to happen? I'm going to shift this guy over there and shift this guy over there. So I'll get K1 L2 T1 plus K2 L1 T2 is equal to, I'll have K2 L1 T from here and plus K1 L2 T. Now I just wanted temperature, right? So T is common, like you can see in both these things. So everything else will go down here. So K1 L2 T1 plus K2 L1 T2 divided by, from here, K2 L1 plus K1 L2 is equal to temperature. So that should be your final answer. I hope this is clear. This is your final answer. Yes, I hope this is clear. I hope this is clear. Shall we proceed ahead to the next type of question? All the minions out there, have you understood it? Yes. Dear, don't worry about convection. Convection is basically, it's not there in the syllabus, just you should understand what is convection. Convection is when particles themselves move from one point to the other. Just rewind the video back. At the beginning, I have explained convection. Conduction, the particles stay there, they just transfer the energy. Understand? So that's the difference. Okay, so that's the answer. We just figured it out. How about these type of questions? These type of questions are also very common, and sometimes people get confused over here. Again, over here, see what is asked. There are 3 rods, different case, same length, same area. Temperatures are given. The question is, what is the temperature of the junction? Now, the way to solve these kind of questions, yes, something like resistors. So all you need to think is first mark the directions of current, but heat current this time. So this is hot, those are relatively cold. So most likely the heat is going to come like this. Alright, so the heat is going to come like this, and it is going to get distributed in both these sides. So maybe one part of the heat goes here and the other heat goes here. So heat which comes here will get distributed. Doesn't it remind you of Kirchhoff's current law? Current in is current out. Same thing can be applied here. Remember, everything in electricity is applicable over here. Okay, so dq by dt in the first rod is dq by dt in the second rod plus dq by dt in the third rod. That's it. Now just start substituting values. dq by dt in the first rod, k is 3k, area is a, because all of them have the same dimensions, keep that in mind. High minus low, which is 100 minus low, divided by length, I just assume it as length L, is equal to, think about it, T minus 50, be careful. So it will be 2k into A into high minus low, because heat is going from high to low, keep that in mind, not 50 minus T, that's a common mistake. So T minus 50 divided by L plus again K into A into T minus 20 divided by L. Cool. K gone, A gone, L gone. So I have 3 into 100, 300 minus 3 into T, 3T is equal to 2 into T, 2T, 2 into 50, 100 plus 1 into T, T, 1 into 20, 20, so minus 20. Now just rearrange. So bring that 100 here. So 300 plus 100 plus 20 is equal to 2t plus t plus 3t. Therefore 2 plus 1 plus 3, 60, and 300 plus 100, 400, 420. So therefore T is equal to 70 degrees Celsius. That's the answer. Yalni, I think you got minus 70. I think maybe because of some sign convention mistake. So this is the correct answer, plus 70 degrees. Why does 2K branch have more current? Okay, I do not know whether it has more current. I have just assumed, I have just split it randomly. Even if I had put 3 arrow marks, 2 arrow marks here, nothing will change in the formula. But logically speaking, think more the temperature difference, more the current. So I just thought maybe because the temperature here is bigger, so the difference will be smaller. So most likely current will be less and current might be more. But again, you cannot say that because the conductivities are different. So it's okay, just assume to be something. Eventually you'll get the answer. Yes. Oh, acha, you wrote 70. Okay, fine, Yalini. Yes. Yes, hello computer, definitely you can crack JEE by yourself and you need proper mentoring. Just self-study? No. Just attending lectures? No. Both, when they form a very good combination, that's when you crack. Alright, let's get going to the next question. Here it comes. There are two vessels of different materials, okay? And in every respect, same ice, and they melt in 20 minutes and 40 minutes respectively. What is the thermal conductivity of the metal? Okay, now I'll tell you how to solve these questions. These kind of questions do come in the JEE examination, mains as well as advanced, even in bits sometimes. Imagine this is the ice cube and it is melting. Okay, now first let's imagine the box. That box is very important. So that box is going to be something like this. Something like this. Okay, I'll just try and draw it, how it's going to look like approximately. Okay, and maybe like this, like this, like this, like this, like this. Okay. Okay, cool. Okay, now that red color thing is that thin box that you can see. I will be covering radiation tomorrow. Today is one shot for conduction, tomorrow is one shot for radiation. Don't worry. Very good, all the minions. Now, think about how the heat is going to flow from the ice to the surroundings or from the surroundings to the ice. Ice is colder, surroundings are hotter. Heat flows from hot to cold. So, the heat is going to come from all these sides, literally. Think about it, it's going to come from here, it's going to get attacked 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 from behind, it's going to get attacked. Is there any side left? No. 1, 2, 3, 4, 5, 6. 6 sides, all the 6 sides it's going to get attacked. The heat is going to come from everywhere, isn't it? And when the heat is going to flow, it's going to flow through the thickness of that conducting box. So this is that thickness. This is that thickness. That thickness is almost same everywhere. I will call it L. Everywhere it's the same material and same thickness, so it's L everywhere. So think about it, the rate at which the heat flows, okay, which is dq by dt. The rate at which the heat flows will be K of this material into A. But this area is the total area, total surface area, because heat is coming from all the sides. A surface, that's very important, into temperature difference, temperature of who is hotter? Surrounding minus temperature of ice, of course, divided by, this is total surface area, I hope you get this, divided by the thickness, which is roughly L. Now, this heat flow rate, okay, this heat flow rate is going to be how much heat flows in how much time. Remember, the heat is flowing to melt it, okay, to melt it. So how much heat is required to melt anything? ml. You have learned this in specific heat capacities. M into latent heat. In how much time? Let's say T. So this will be equal to K, area of the surface, okay, into temperature of the surrounding, temperature of ice, divided by length L. This is latent heat, this is thickness, do not get confused. Now why I did this? I could have done this in a much simpler manner also. Reason why I did this, sometimes they will ask you numerical questions. Yes, numerical questions to find how much is the time, and they will give you every bit of detail over here. Surrounding temperature 40 degrees Celsius, ice 0, length or thickness 2 millimeters, 5 millimeters. Area they will not give, they will give you the size of the cuboid or the cube. Side length they will give, and K will be given to you. Latent heat of ice, everybody knows how much is it, 80 calories per gram converted into joules. Mass of the ice will be given to you. Time is something which you will have to find out. Those kind of questions will come. Yes. So yes, do not get scared by so much of info. The reason why I did this is because you should know the formula. I know a lot of websites and books, they'll ignore this formula. This is proportional to that, that is proportional to that. Blah, 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 blah. 1:2, 2:1, gone, done. So you will miss the main concept. That's the whole point. You should not miss the concept. Okay, so the correct answer, ratio of conductivities. Time, you can see, is inversely proportional to K. So therefore, T1 by T2 is 20, isn't it? Divided by 40, which is 2:1. That is the answer. So we were just interested in this time and this K. Okay, I hope this is clear. Very good, very good. Great, great, great. Now is the homework time. This is your homework. Yes, this is the first question for homework. 3 rods are given. Very beautiful question. The question is find the temperature at C. Looks like a triangle. Use the logic of resistors. You are going to get it. Okay, the answers have been put on the next slide. Again, a problem of resistors must remind you of something which you have studied in current electricity. Somebody's bridge. Whose bridge? Think about it. Looks like that. Okay, so solve this. Next question. Again, answers are kept on the next slide. And do not forget to join our Telegram group where you will get all the important pieces of information, notification, etc. Yes, and there is one very important thing. Yes, Diya, the class timing, everything will be announced on the Telegram group. Join it. It's there in the description box. But every day you will find me over here at 7 o'clock. That's my timing. But before you go, one very important announcement. Do you know what is the important announcement? Yes, tomorrow the announcement will be done for the date sheet for CBSE board examinations on this channel as soon as it comes, and all the important stuff related to that. So stay tuned. I'll be posting a video on this channel of yours. Do not forget to hit the subscribe button so that you do not miss that notification. Share it with your friends so that they do not miss it, and smash that like button out there so that we get all the love, support for conducting more such sessions. And remember, the JEE crash course is for all of you, all the students who want to crack the JEE examination. You are going to need a very strong, motivated, dedicated team who is going to solve all your doubts, and you need an institute which has a proven track record. And believe me, you don't want to go back to those classes where you get distracted. There are a lot of people talking nonsense. You need an environment which is very focused on the current stuff. So for all of you, in the last few days, we have come up with the crash course where you are going to get unlimited doubt solving. You're going to get test series with discussion, in fact 20 test series, and special tips and tricks session with our mentors. And also all the syllabus will be covered from 11th to 12th in these few weeks. So this crash course details are there in the description box below. Do not forget to check it out. That's very important. And remember, the crash course has started on 28th, but you can watch the replays, and please use the discount coupon so that you get the offer of or the benefit of 20% discount. So 10,000 will come down to 8,000 when you use the coupon code SHCC. All right. So bye bye minions. Do not forget to check out all the links in the description box. See you tomorrow for radiation. Take care. Bye bye. Have a great time. See you.